evening. Today we are going to finish our chapter. We only have a small part left to explain today. Seismic waves. Earthquakes produce both longitudinal waves and transverse waves. So, you know earthquakes, right? So earthquakes produce two types of waves. Longitudinal, we call these waves P waves. So P waves are longitudinal. S waves are transverse waves. Remember, S transverse. Okay, so P longitudinal. That are known as seismic waves. So seismic waves are the waves, they come from what? From earthquakes. So earthquakes produce seismic waves, and these seismic waves, we have two types of them, longitudinal and transverse, P and S waves. Here are they. P wave is a longitudinal wave, back and forth, rarefaction and compression. S wave is a transverse wave. It has what? Crest and trough, up and down, a crest and trough, up and down. These seismic waves travel through the earth at speeds up to 13,000 meters per second. This is the speed of seismic waves. When seismic waves pass under buildings, severe structure damage may occur. That's what happens. If the earthquake occurs under the sea, the seismic energy can be transmitted to the water and produce tsunami waves that may travel for very large distances across the ocean. This is a tsunami, and here is F. The seismic waves pass under buildings, and here it passes under ocean. If the seismic wave passes under ocean. Okay, that's all. We're done with our lesson or our chapter, sound waves. Now we will start solving some questions from paper 2 together. Let's start. The first question, let's read together. A sound wave travels through air as a series of compressions and rarefactions. Which row correctly compares the air pressure in a compression and the air pressure in a rarefaction to the air pressure nearby where there is no sound wave? You remember yesterday I told you about the air pressure. What I said? Look here at this figure. I told you yesterday that in compression, because the particles are close to each other, we have high pressure. That's why when we draw the sound wave as a transverse wave, or the pressure of it, what do we draw here? The compression, we draw it as a crest. And the rarefaction, we draw it as a trough. So compression is what? High pressure, the area of high pressure, and rarefaction, the area of low pressure. So which one is the answer? Air pressure in a compression, it has to be higher. Air pressure in a rarefaction, it has to be lower. So the answer is B. The second question. A sound wave has a certain amplitude and a certain frequency. This is wave number 1. A second sound wave is quieter and lower in pitch than the first sound wave. The second wave has, before I look at the answers, I want you to think with me. A second wave is quieter, louder, quieter. We said louder depends on amplitude. So quieter, it means what? Low amplitude. Right? Small amplitude. Lower in pitch. Pitch depends on what? Frequency. So low pitch, it means low frequency. So We are looking for which answer? The answer is D. Smaller amplitude because it's a quieter sound and smaller frequency because it's lower in pitch. Okay? The sound from a loudspeaker must pass through two materials to reach a microphone. Here's the microphone, here's a loudspeaker. I have material 1 and material 2. Which combination of materials gives the shortest time for the sound to reach the microphone? What do you think, girls? Do you remember? Where the sound moves faster or the fastest in which type of materials? Solid, liquid, or gases? We said in solid because the particles are close to each other. So, let's read. Air, hydrogen, no. Air, water, no. Copper, aluminium, for sure, yes. Let's read the last one, water and oil. No, the answer is C because both of them are solids. So, shortest time, it means fastest, okay? In which two materials the sound wave will move faster. Good? So the answer is C, copper and aluminium. An echo sounder in a ship produces a pulse of sound. So here, echo sounder produces a sound. The echo is received by the echo sounder after 2 seconds. So time equals 2 seconds until it goes and comes back. The speed of sound in seawater is 1,500 meters per second. This is the speed. What is the depth of the seawater below the ship? I want to find the depth or distance. So what I will use? Now the givens, time 2 seconds, speed 1,500 meters per second. They want you to find distance. You remember the formula, speed equals distance over time. But we said always in equal questions, what you have to do, you have to multiply the distance by 2. Because if the distance here is 1,000, for example, you go back and forth, okay? Back and forth. So 1,000 and 1,000, the distance is 2,000. Because it's not only one way, it's two ways. What is the depth of sea water below the ship? The depth 2 times d over t, 1,500 speed equals 2 times d over the time, which is 2. So distance equals 1,500 meters. Girls, this distance, it's not the depth. This distance is not the depth, it is the distance for the sound or sound wave has moved. Now the depth, it's half of this distance. It means 1,500, here is it. This and this together, down and up together, 1,500. So the depth is only from here to here, so I want to take half it. So what is half of it? This is what? 750 meter, 1,500 over 2, so it is 750 meter. This is the answer. Okay, is it clear why it's 750 meter? Next question. Sounds are produced by vibrating objects. A certain object vibrates, but a person nearby cannot hear any sound. So, I have object near to me and this object is vibrating, but I can't hear the sound of this vibration. What do you think? What is the reason? Let's read the answers. The amplitude of the sound waves is too large. For sure, no. If the amplitude is too large, it means that this sound is very loud. So for sure, I will hear it. The frequency of the vibration is too high. Yes, maybe. Because we said that we have a range of frequency from 20,000, from 20 hertz to 20,000 hertz that we can hear with this range only. If the vibrations that are more than 20,000 hertz or less than 20 Hz, we cannot hear these sounds, right? So, for sure here, this is the answer. But let's read the rest to make sure that this is the correct answer. The sound waves are transverse. Wrong, we don't have a sound wave. That is a transverse wave. The speed of the sound waves is too high. The speed is too high. So what? Speed? No, it's not. This is not the reason. Even if the speed is high, we can hear the sound. Okay, so the answer is B. The frequency of the vibration is too high. Two sounds, X and Y, are produced by loudspeakers. The amplitude and the frequency of each sound wave is given in the table. Okay? The amplitude and the frequency of each sound wave is given in the table. Amplitude and the frequency for each sound. How does sound Y compare with sound X? But let's look at the table and compare between them here before we read the answers. Let's compare the amplitude first. Y, how it is compared with sound X. It has more amplitude, so it means that Y is louder than X. Let's see the frequency. Frequency is less, so it means that it has what? Low pitch. Y has lower pitch than X. So which one is the answer? The answer is B. Y is louder and has a lower pitch. Okay? A lighted candle is placed in front of a loudspeaker that is making a loud, steady note. The candle flame vibrates because of the sound wave. Here's the speaker and here's the candle. Which type of waves are sound waves and in which direction does the flame vibrate? For sure, we know that sound waves, they are longitudinal waves and they move parallel to the direction of motion and or we can say back and forth. So how the flame will move? Back and forth horizontally, not vertically. So the answer is C, longitudinal, and the motion is horizontal. In an experiment to measure the speed of sound, a student uses a stopwatch to find the time taken for a sound wave to travel from X to Y. She does this 6 times. Sound travels from X to Y. She does this 6 times. The table shows her results, measurements, and the time. Which value for the time should be used to calculate the speed of sound? What do you think? Which one from these values we are going to use? For sure, none of them. Why? Because we have to find the average. She did that 6 times to get an accurate answer. So we take the average, you add them all, you divide by 6, the answer is 0.6 seconds. C. That's all, girls. I hope everything is clear. Study well, and if you have any questions, you can ask me anytime. Thank you.